Hello and welcome. Today we're going to be talking about the mole. Okay, so you may have heard of this thing called the mole. It's a method of measurement used in chemistry, a standardized unit of measurement. And what it represents is it measures the number of particles of something in a substance. Okay, so specifically, you may have heard of this thing called Avogadro's number. And this is the main number we'll be dealing with when we talk about moles. This number represents 6.02 times 10 to the 23rd. And this is the number that we're going to be using when we want to find the number of particles in however many moles of something. So in 1 mole of any substance, there are this many particles, whether those particles are atoms or molecules, depending on what it is. There are this many particles in that in 1 mole of any substance. Okay, that's what Avogadro's number represents. And this number originally, if you were curious, this number's origin originally came from this guy Avogadro, who discovered that this is the number of atoms that are in 12 grams of carbon 12. But that's not super necessary for you to know right now. I just thought you might be curious about the origin. Yeah, basically the mole is a standard unit of measurement that represents Avogadro's number of particles. And it's specifically, the mole is very useful for stoichiometry. So if I write out a chemical reaction here, just a standard, any chemical reaction. Okay. So in this chemical reaction, we have 1 particle of methane that has to react with 2 particles of oxygen gas. Okay. And that's, I know that because of the coefficients on each of these molecules here. So every 1 molecule of methane needs to react with 2 molecules of oxygen gas. So in order to make that happen, we can't just use mass here. We can't just use 1 gram of methane and 2 grams of oxygen to react here, because due to their different molar masses, they may not have even close to the same number of particles. Okay. So in other words, 1 gram of methane does not have the same amount of particles as 1 gram of oxygen, which is why we need to use the concept of the mole here. So if we use 1 mole of methane and 2 moles of O2, then the reaction will be balanced, because then it's on the basis of particles. And if we want to interconvert between mass and moles, the way that we do that is using the molar mass. And the molar mass is different for every compound or element. So the way that we would do that is moles times molar mass equals mass, okay? And vice versa, mass divided by mass in grams usually, divided by molar mass equals moles, okay? And also, sometimes you may get a problem asking you how many particles are here, or they give you a certain number of particles, and they ask how many moles are here, or how many grams are here. Then what you could do is, if you want to find the number of particles in something, you could do number of moles multiplied by Avogadro's number equals number of particles. And you could also do number of particles. If you want to find the number of moles, you could also do number of particles divided by Avogadro's number equals the number of moles. So those are some things that you can do with moles.